Subtract the following two rational expressions. The first is 2x minus 2 over x squared plus 4x plus 3, and the second is x minus 1 over x squared plus 5x plus 6. Ooh. Now the first thing to notice is that these two denominators are not the same, right? So what we have to do is to get them to look the same, and how we do that is by using the LCD. So we have to factor the denominators and then build the LCD from the factors, just like how you would with numbers or fractions. So the first thing we should do is factor out, as I said, each of these denominators. So I'm going to rewrite the expression with the factor denominators. So this is going to be 2x minus 2 over, factoring this becomes x plus 1 times x plus 3, right? Because 3 times 1 is 3, and 3 plus 1 is 4. And then the second denominator factors into x plus 3 and x plus 2, right? Sorry, I blanked for a moment there, but let's check just to make sure. So foiling this back in, we get x squared plus 3x plus 2x plus 3 times 2, which is 6. So yeah, that's going to give us what we want. There we go. Took a little bit, but we got it. So now we get to build the LCD from the factors. So the LCD of the denominators is each of the factors of each of the denominators non-repeating, without repeating any of the factors. So we have x plus 1, we have x plus 3, there's another x plus 3, which we don't need to write down, and then finally there's x plus 2. So this is the LCD, and this is what we need to go by to turn what we want each of the denominators to look like, right? So that they can be the same denominator and we can then combine it. So now how we do that is that we look at the denominator and fill in what's missing in terms of the LCD. So for example, doing the first one, in the LCD, in the denominator, there's an x plus 1 and an x plus 3, but there's no x plus 2. So what we do is we multiply the denominator by x plus 2 so we can get it to look like the LCD. But remember, this is an expression, so whatever we do to the denominator, we also have to do to the numerator so that we can balance them out. So we'll multiply the top and bottom by x plus 2. So now for the second one, we have an x plus 3 and an x plus 2, but no x plus 1. So here, we do the same thing, but with x plus 1. So we multiply the numerator and the denominator of the expression by x plus 1. So now, let's combine. So multiplying 2x minus 2 times x plus 2, in the top we get 2x squared plus 4x minus 2x minus 4, right? And the denominator is x plus 1, x plus 3, x plus 2. And then in the second one, for the numerator, you notice this is x minus 1 times x plus 1, which is difference of squares, right? So in the numerator here, you're going to get x squared minus 1. And if you don't believe me, you could just FOIL these in and you'll see that the x terms are going to cancel out. And then in the denominator, we get x times x plus 3 times x plus 2 times x plus 1. So now, notice, even though they're written in different order, multiplication is commutative, so these two are exactly the same. So now that we have a common denominator, we can use the rule for combining rational expressions with the same denominator, which is the same for fractions, right? So if you have a rational expression and you're subtracting another rational expression from it and they have the same denominators, the result is the difference of the numerators over that common denominator. So, keeping that in mind, let's combine the numerators and put them under that common denominator. So we got 2x squared plus 4x minus 2x becomes just 2x minus 4, then minus the quantity x squared minus 1. Because remember, this negative sign here is applied to the whole thing, right? So we're going to have to distribute that negative in at some point, but for now let's just keep it under parentheses. But just be really careful about that negative. It goes into the whole thing. It's not just for the first term. And then in the denominator, we just write our LCD, right? Because that's our common denominator. So now we're in a position where we can reduce. So let's did what I proposed to a little bit before. Distribute that negative into that difference. So we get 2x squared plus 2x minus 4 minus x squared plus 1 all over that common denominator. And now, since we don't have any more parentheses to take care of, and we don't have any multiplication or division to take care of in the numerator, at least, we follow our PEMDAS, and now we add and subtract. So combining like terms, we got a 2x squared and a minus x squared. So that's going to give us positive x squared. Then we just have a 2x by itself. And then we have a negative 4 and a positive 1, which is going to give us negative 3 in the numerator. And then in the denominator, we leave this as is. And there's no point in foiling in the denominator and combining these three products, mainly because at the very end we're going to factor and reduce, right? Which is why I didn't bother foiling these in. I just kept them as x plus 1 times x plus 2 times x plus 3. And you'll see the reason for this madness in just a second. So now, factoring the top, this quadratic equation factors into x minus 1 times x plus 2, right? Let's check to make sure. X squared plus 2x minus x minus 2. Nope. See, everybody makes mistakes. Ah, I see. I see what I did. So this becomes actually x plus 3 times x minus 1. I think that should be the ticket there. But let's check to make sure. This gives us x squared plus 3x minus x minus 3. Alright, well, you know, second time's a charm. So in the denominator, we'll just rewrite it. And now notice that in the numerator and the denominator, there's an x plus 3 that we can factor and take out. Cancel out, rather. So our final answer is x minus 1 over x plus 1 times x plus 2, since there isn't anything else we can do to cancel out any terms.